Hey guys, welcome back to a new video, and in this video we're gonna see about coroutine testing. So we're gonna start from the basic and see how to write unit test cases for our coroutines, and apart from this we're gonna learn about a run test coroutine builder that we're gonna use to write a test cases in which coroutine involves. So we're going to talk about what is TestDispatcher, what is UnconfinedTestDispatcher, what is StandardTestDispatcher, and apart from this we're going to see how to test our repositories, what are the best practices to write unit test cases for your repositories. Apart from this we're going to also see how to write ViewModel test cases and what are the things that we should take care into our mind when we wrote ViewModel test cases. And apart from this we're going to see how to test flows. So basically here we're going to see how to test hot flows, cold flows. So cold flows is very easy, but hot flows is a little bit tricky to write test cases. So we're going to look into this and we're going to discuss everything that we need to know in order to write our coroutine testing. So let's get started and see how we can do all of these things. Go to the description box where you can find my GitHub repository link. Go there, download the project and open up into your Android Studio. So once you open up the project, you're gonna see this kind of package structure. The first package would be our data source. So within our data source, we are having a data source interface, and this interface contains two different functions, emit and counts. So this interface implementation will be written with the help of two different classes. The first one is cold data source. So here I'm using cold flows, and that is why we will call this cold data source. We don't use emit function here. We are using count function in order to return back the cold flow. So cold flow that has an integer value in it 1 2 3 4 5 6. Once you open the hot data source, so hot data source is actually using hot flows. So in order to use hot flows, I'm using mutable shared flow here, and this mutable shared flow is eventually a hot flow. So we will mimic the hot flow behavior by the use of these two functions. So emit will eventually emit values, and count is return back the shared flow, or you can say hot flow. Open up your repository package, and within this package we are having one interface that has a couple of functions in it, and the implementation of this user repository will be given with the help of user repository implementation. And the constructor of this particular class has data source, and the class member variable would be an scope, or you can say a coroutine scope that has dispatcher.io in it, and have a late init variable list that has a type of mutable list of string. So this is actually used to initialize our list with mutable list of, and here I'm using a coroutine, basically launch a coroutine, and then after I'm gonna initialize my list with the help of mutable list of. Fetch user is ultimately return back you the list that we are having in here with as a class member variable, and here I'm using with context dispatcher.io. Insertion will be happen by the help of insert database function, and here I'm gonna create a new coroutine, and then after I will provide some delay with the help of a repeat function, and eventually I'm gonna add that list which is coming from this function as a parameter to the list that we are having in our class member variable. And similarly we are having here emit. So emit is actually used to use our data source dot emit. So basically we are having emit function in our data source interface, and that function we're gonna use here in the emit function. Get score is eventually use my data source dot count function. So it's a very simple implementation of my repository. Now once you open this ViewModel package, in our ViewModel we are having a mutable state flow and having a function naming get user that eventually use a ViewModel scope.launch to launch a new coroutine, and within this I'm creating a list of user and simply update my mutable state flow. Alright, so let's begin with a very basic example of coroutine testing. So for that, go to your user repository implementation, and here I'm going to create a suspend function naming hello world, and return type would be string, and I'm gonna use here delay of 1 second, and eventually it will return hello world. Alright, so now it's time to write a test case for this hello world. So in order to write a test case, go to this particular package that has test in front of them. So here I'm gonna create package naming repo, and within this repository I'm gonna create a class naming testing coroutine. So this is a class, and within this class I'm gonna write my first test case. So you can use test annotation if you want to create a test case, and here I'm gonna create a function naming test hello world. We are having here runTest coroutine builder. So this runTest coroutine builder will eventually build a coroutine that is used for our testing. This runTest is coming up from my coroutine test library, and this test library is present into my libsversion.toml file over here. Okay, so in order to use the dependency, you can go to build.gradle.kts and use test implementation and pass your dependency over here. Simply sync your project. So if you are using test implementation, that means this particular dependency is only available into your unit test cases over here. Go to your test coroutine, and here I'm gonna create my repository because I want to test my hello world. So for that I need repository. So user repository implementation, you can pass your cold data source. Okay, now it's time to perform the assertion. So assert equals, import this assert equals. So the first parameter would be the expectation. So my expectation is hello world, and this expectation is from repository.hello world function. That means if it return hello world string, so our test case will pass, otherwise it fails. Execute it. Here you can see our test case passed successfully. So now it's a very good time to talk about this runTest coroutine builder. So runTest coroutine builder is used to build a coroutine that we're gonna use into our test cases. Under the hood, it uses test scope. As you already know, every coroutine requires coroutine scope. This coroutine scope tells us a coroutine about its life cycle, its dispatcher, and pretty much everything about it. Similarly, here we are having test scope. That test scope contains a test dispatcher. So this test dispatcher is an interface that is implemented by the two different classes, StandardTestDispatcher and UnconfinedTestDispatcher. The most important thing here is test scheduler. So all of your tasks will eventually schedule into this test scheduler. We will see what are the use case of test scheduler and how the task is scheduled into our test scheduler, and what is the main difference between StandardTestDispatcher and UnconfinedTestDispatcher. So for that, I'm going to create another test case, and I'm going to call this test repository, use a runTest coroutine builder, and here I'm going to create my repository, which is a user repository implementation, and the requirement of this thing is data source. So I'm going to pass my cold data source, even though we are not using cold data source here, but for the requirement we have to pass it. All right, so now it's time to initialize our database. So open up this thing. This database initialization eventually launch a new coroutine, and within this we are initializing our list with the help of mutable list of. Now I'm gonna use a repository.insert database and simply insert a list of A, and I'm gonna duplicate this thing few more times. So we are having here B, we are having C, we are having D, and lastly we are having E. Alright, so these are the insertion that I'm having. Open up this insert database, and here you can see we launch a new coroutine, and after that we provide delay. So this delay depend onto the list size, and eventually we add all of the lists that we are receiving into our list, which is present on the top. Go back to your testing coroutine. Now I'm gonna use assert equal, and here we are having a list of A, B, C, D, E, F, G, H, and this is coming from my repository.fetch user. So open up this fetch user. Here you can see we are having fetch user function that eventually use with context dispatcher IO and return back the list. Go back to your testing coroutine. Now once I execute this test, I assume this test will pass. Alright, so you can see over here our test case fails, and the expectation is A, B, C, D, E, F, G, H over here, but we are receiving A, C, B, D. Why it is happening? So in order to see what is the problem, you should go into your test case and visualize your code line by line. So first is this initialization, which is a very common thing. Second, we are having database initialization. So once you open the database initialization, here we are using scope.launch. That means we launch a new coroutine, and within this we initialize our list with the help of mutable list of. Go to your testing coroutine, and here after that we are having insert database. So once you open the insert database, again we are launching a new coroutine, and after that we produce some delay, and just after that we perform the insertion. That means this is a task, this is also a task, and this task eventually goes into our test scheduler in a form of queue. So in our queue, first it will have database initialization task, then we have insert database that has a list of A, then we are having insert database that has a list of B. Similarly, we are having C, D, E, F, G, H. All right, and every task has a timestamp. So let us say this has a timestamp of now. Similarly, we are having this timestamp now. Similarly, for this I am having timestamp now. Similarly, for this I am having timestamp now. Similarly, for this we are having timestamp now. For this, let us suppose we are having 100 millisecond delay. That means these operation will be executed by our test scheduler immediately, and this thing will take little more time. Basically, this will execute after 100 millisecond. So this timestamp is given by me. It's a random thing. So it is not like that. It depends on the resources. It depends on the scheduler, how it schedule their work. So for the understanding, let us assume this thing has been completed by our test scheduler immediately, and only this thing is left. This is because it will take little more time. And once you open the insert database, you can see based on the list size, we will provide delay. And this time list size is pretty much 4. So due to this reason, it will take little more time. So due to this reason, these are the operation that is performed, that is executed by our test scheduler, but this is not. This is because it will take little more time because of the delay that I put into my insert database. And due to this reason, when we reach over here, we got all the 4 but not this. So how can we fix this? Because this is a very common thing that we use into our production codes. So in order to fix it, we are having few different extension functions. So first one is a run current. So run current eventually run all of the tasks that has a timestamp now. That means this thing will be executed if we are using run current. Second, we are having advanced time by. If you pass 100 millisecond, that means before 100 millisecond it will execute everything. We are having advanced until ideal. So this will execute everything that is present into our test scheduler, and this is a very common thing that we use into our unit test cases. So once you execute this thing, you can see over here insertion is pretty much done. Now expectation is A, B, C, D, E, F, G, H, and we are receiving A, C, B, D, E, F, G, H. So you can use sorted here. And now when you execute this test case, your test case will pass. So now the thing is, when you uses advanced until ideal, it will perform all the tasks, all the things that is present into our test scheduler, and after that it goes into this particular line. So due to this reason, our test case will pass. So this is a case of standard test dispatcher, because by default run test has a test scope, and within the test scope we are having standard test dispatcher by default. Now what will happen if I use unconfined test dispatcher and remove this advanced until ideal and execute this? Here you can see our test case pass. Now what is the difference between standard test dispatcher and unconfined test dispatcher? So standard test dispatcher uses test scheduler. It will put all of the tasks into the test scheduler in a form of queue, and when you use advanced until ideal, then only it will execute all of the task that is present into our test scheduler. And if you are not using advanced until ideal, then it will execute only the tasks that are having timestamp now. When it's come to unconfined test dispatcher, it start the coroutine execution eagerly, and due to this reason our test case is passed with the help of unconfined test dispatcher, even though we are not using advanced until ideal here. So once you run this thing, you can see this test case is passed. This is because unconfined test dispatcher execute your coroutine eagerly, but in standard test dispatcher we put all of the tasks into our test scheduler, and after that we start executing. And due to this reason, if we are using again, just remove this thing with standard test dispatcher and execute this thing again, you can see your test case will fail, and the reason is already I told you. Second difference between standard and unconfined test dispatcher is, if your test cases have a lot of concurrent code and you are writing test case for this concurrent code, never use unconfined test dispatcher. If you are using unconfined test dispatcher, eventually sometimes your test will pass and sometimes your test will fail. So always use standard test dispatcher when your code has a lot of concurrency. Now we're gonna do some modification in our user repository implementation as our best practices told us. So go to your user repository implementation, and here I'm gonna create a private variable naming IO_dispatcher, and this is coroutine context, which is initialized with the help of dispatcher.io, and I'm gonna use this IO_dispatcher here and here. So the thing is, if you are passing IO_dispatcher as a constructor parameter, you can replace this dispatcher with the help of standard or unconfined test dispatcher into your unit test cases. So this is the only reason why I am passing IO_dispatcher into our constructor of user repository implementation. Now go back to your testing coroutine and remove this standard test dispatcher, and in place of IO_dispatcher I'm gonna pass standard test dispatcher. Now when you execute this test case, you are having few problems, and the problem is, as I already told you, you should never create two test scheduler. You will only use a single test scheduler and share that test scheduler across your test case. But here what I am doing, runTest has a test scheduler and standard test dispatcher is also have a test scheduler, and due to this reason we are having here two different test scheduler. And I told you, never use two test scheduler into your test cases. If you are doing this thing, ultimately your test will break. So how can we fix it? Well, in order to fix this problem, you can pass the test scheduler that we are receiving from this runTest. Now execute this test case and your test case will pass successfully. So now we are going to see how to test Kotlin flows. So if we are talking about Kotlin flows, we are having two different type of flows, hot and cold flow. So first we will begin with cold flows. So for that I'm going to create a test case here, and I'm going to call this test function naming test cold flow, run test, and I'm going to create my repository, which is user repository implementation. And because I want to test cold flow, I'm going to pass my cold data source. If you open this cold data source, you are going to see we are having counts, and this count will return me a cold flow that having 1 2 3 4 5 integer value. Go back to your testing coroutine, and here I'm gonna use a variable naming list, and within my repository.getScores. So getScores uses datastore.count function. Go to your testing coroutine, and here I'm gonna use toList. So ultimately it will give me a list of integer that we are receiving from dataSource.count function. So it's time to write assertion. So assert equals, so I expect my list dot first index value would be 1. Execute this test case. As always, it pass. Alright, so this is a way of testing cold flows. I mean, testing cold flow is very easy. Now we are going to see how to test hot flows. So testing hot flows is a bit tricky. So test hot flow, and I'm gonna use a runTest here. I'm gonna create my repository, which is user repository implementation, and I'm gonna pass my hot data source. Here I'm gonna use a repository dot getScores, and I'm gonna use collect latest. Okay. On the top I'm gonna create a variable naming list, which is a mutable list of integer. Okay. So when we receive anything here, I'm gonna add that thing into my list. If you open this repository implementation, you are going to see over here, if we are using emit, so this will ultimately use our data source.emit. And when you open our hot data source, eventually if you are using emit, it will emit the value into our share flow, and by the help of count we receive that hot flow. Go to your user repository implementation, and here we are using counts. So ultimately if you are using getScore, you will receive the share flow, and if you are using user repository implementation.emit function, it eventually emit the value. Go back to your testing coroutine, and here I'm gonna write assertion. So assert equals, I assume my list dot its first index will have 1. Now this only comes if I'm emitting something, so I'm gonna emit 1. Execute it. Now this test will execute for eternity. Now the reason behind it, hot flow never stop its data streaming. Hot flow execution will never stop, and due to this reason our test case will wait for near about 1 minute and eventually it fails. Alright, so our test case fails. As I told you, it will wait near about 1 minute, and after that it says something after waiting for 1 minute the test coroutine is not completing. So how do we fix it? So in order to fix it, we are having a few approaches. So the first approach is using launch, and within this launch I'm gonna pass unconfined test dispatcher. Now within this I'm gonna start collecting this thing, and make sure to take this job into a variable, and once we done the assertion I'm gonna cancel it. So job dot cancel. Now if you execute it, you will see our test case will pass successfully. Similarly, if you don't want to use this job variable and the manual cancellation, you can use one more thing over here, which is background scope dot launch. Now remove this job dot cancel. So this background scope eventually stop its execution once we perform the assertion. So simply execute it, and here you can see it passes successfully. So this is a way using which you can test hot flows, and in hot flows you can create background scope dot launch in order to collect your hot flows, or you can use your manual launch coroutine builder and take that job into a variable, and eventually after the assertion you can cancel that job. It's totally up to you, but for me I'm always using background scope dot launch. So this is all for our testing hot flows and cold flows. One library that you can use for flow testing, which is Turbine. So you can go and check it by yourself. It's very easy. Now we are going to write unit test cases for our ViewModel. So for that, go to your user ViewModel, and here we are having one function, and within this function we are using ViewModel scope dot launch a coroutine, and within this we are creating a list of user naming A and B, and simply update our mutable state flow. So let's write a unit test case for this particular function. So go to your testing coroutine, and here I'm gonna create a function naming test ViewModel, and I'm using runTest, and on the top I'm gonna create this ViewModel, which is user ViewModel, and here we are having function get user, I call it, and ultimately I'm gonna use assert equals, and I believe we are having a list of user A and user B, and this will ultimately coming from our ViewModel mutable state flow value. Alright, execute it. Alright, so our test case failed, and the problem is, so module with MainDispatcher has failed to initialize. For TestDispatcher statement from Kotlin next coroutine test module can be used. So the thing is, ultimately ViewModel scope dot launch uses dispatcher main immediate. So here we have to set our main dispatcher, then only our ViewModel test will execute. So to do that, we are having here dispatcher dot set main, and I'm gonna pass here unconfined test dispatcher. Why I'm passing unconfined test dispatcher? Because unconfined test dispatcher start our execution eagerly. So due to this reason we pass unconfined test dispatcher. Within this I'm gonna pass unconfined test dispatcher. This is because ViewModel scope dot launch have a very similar behavior that we are having with unconfined test dispatcher, like we execute our coroutine eagerly. So due to this reason I'm gonna pass unconfined test dispatcher here. And lastly, when we are done with our test cases, I'm gonna use dispatcher and call a reset main. And now when you execute this test case, your test case will pass. Now the thing is, if you are having a lot of test cases for your ViewModel, you have to write this piece of things again and again. So what we are going to do, we're gonna create a class called MainDispatcherRule, and within this we are having a variable naming TestDispatcher. Type would be TestDispatcher and initialize with unconfined TestDispatcher. Ultimately it will extend TestWatcher. And within this class I am having two different functions. The first one is starting. So in the starting I'm gonna set my main dispatcher with the help of dispatcher.setMain and pass my TestDispatcher, which I was sending from here. And lastly we are having finished, and in finished I'm gonna use dispatcher.resetMain. Now I'm gonna use this MainDispatcherRule on the top. So in order to use this thing as a rule, you can use get colon rule and simply create object of this MainDispatcherRule. and that's it. So when you execute this test case, so first it will go onto this test rule. It set up our main dispatcher by using these two functions, and ultimately after that it start executing our main testing code. So remove this dispatchers reset main and dispatcher set main, and now when you execute it, you are saying your test case will pass. All right. So now very basic question here arise into your mind is what will happen if I create a standard test dispatcher or unconfined test dispatcher, which test scheduler it shares. So the thing is, runTest will eventually check if our main dispatcher is already set, then it uses the same test scheduler that our main dispatcher will use. We don't need to take care about the test scheduler thing because it is under the hood automatically managed by our testing library. So it's a very convenient thing for us. Alright, so that's it for this video. I hope you like this video. In this video we saw a lot of things, and I think you got a complete idea about coroutine testing, how to write test cases for your repositories, for your view model, for your flows. So yeah, that's it for this video. I hope you like this video. So please write your opinion into the comment box. We will meet in our next video where we will write a lot of test cases for our search RSP app. So let's meet over there. Bye.